Hello everyone. Today we shall discuss the topic vapor pressure of liquid-liquid solution. Let us know at first about vapor pressure. We know whenever there is any volatile component taken in an open container, then obviously there will be two processes go on, and these are what? Evaporation and as well as condensation. So during this process, what happens? Equilibrium is being attained, and while attaining the equilibrium, the vapor molecules exert some pressure over the liquid molecules, and at this stage the pressure exerted by the vapor molecules over the liquid surface is called vapor pressure. So here we'll be discussing about such a solution which is made up of two liquid components, and both the two liquid components are in vapor phase. So let's say about two volatile components A and B, and their vapor pressure in the pure state means when they are not mixed with any other component. In free state, in pure state, let's say PA0 be the vapor pressure of the component A and PB0 be the vapor pressure of the component B. Now, as we are going to discuss about the solution, so if we mix A and B, then we will be getting a solution, and let us say the solution as A plus B. That means by mixing these two, we have got a solution, and there will be also a vapor pressure. Now, let's say about the total pressure. Here, the total pressure we can calculate by applying Dalton's law of partial pressure, because you see, by mixing the two components, there will be a mixture. So, here we cannot consider PA0 and PB0 as the summation of the two pressures, because these two are mixed, and therefore these two will have some now different pressure other than PA0 and PB0. So the total pressure will be PA plus PB. Now what about PA and PB? In our previous video we learned about Raoult's law, and according to Raoult's law, PA depends upon the mole fraction of the component A, as well as PB also depend upon the mole fraction of its own component. So this way, students, PA we can write PA0 into XA. Similarly, PB we can write PB0 into XB. So if you put the value over here, as you can see by Dalton's law, we can calculate P total is equal to PA plus PB. So PA is equal to PA0 XA. Similarly, PB is equal to PB0 XB. And this way, if you calculate, the result is in front of you. Here, what can be done? In place of XB, we can put it as 1 minus XA, because mole fraction, here the summation of two components we can write is equal to 1. So, XA plus XB is equal to 1. So, XB is equal to 1 minus XB. And this way, students, the result is in front of you, which you can utilize to solve the numericals. So, XA and XB are the mole fraction of the two components A and B in the liquid phase. As we have already mentioned about the two phases, liquid and vapor phase. So in this solution, vapor phase also exists. Now, what about the vapor phase? So for the vapor phase, we can calculate PA as PA equal to YA into P total, and PB is equal to YB into P total, where YA and YB are the mole fractions of A and B in vapor phase. You have to remember about YA, YB and XA, XB mentioned in different phases. That is, XA and XB are in liquid phase and YA and YB are in vapor phase. And also you need to remember, while calculating the value of YA, YB, then we need to consider P total but not PA0. As you can see, PA is equal to PA0 into XA and PB is equal to PB0 into XB. But for calculating YA and YB, we need to consider the total pressure, because the vapor phase mainly is being maintained here. So this is about the vapor pressure of liquid solution. I hope this video will definitely help you. Any doubt if you find, please ask me or inbox me. Thank you very much.